all those different functions. And what I'm going to talk about today is some realities. Because I love to go back and just share information about what I've actually done. Right? It's not just the theoretical, it's not that. I mean, you talk about all the data centers that you've built, right? Or helped design with that. It's real content. It's stuff that's actually happened. And so you get a lot of people that talk about what I wish we could do or the things we should be thinking about, but they don't actually go back and do something with it. What I want to do is, again, this is real brass tacks, what I've got to deal with. I pay the power bill for eBay. I'm 50% of the carbon footprint for eBay. Okay? And if we have an impact, it's $2,000 a second in our data centers. So, I also have 3 jobs. You heard the one about eBay. But I'm also the chairman and founder of Data Center Pulse, and we've been sponsoring this event. And that's really just to get owners and operators, people like myself, peers together to share information and truly to try and influence the industry. What do we need next? What are our challenges? Wouldn't you like to understand the pulse of what's happening with the consumers that actually buy the equipment and services that you guys are creating? And so that was that organization. I'm also, as of Monday, the vice chair of the Green Grid Advisory Council. And this is also very important because the Green Grid, PUE, CUE, WE, all the other work that's going on that, the Advisory Council advises the board of directors and basically vets through what they're doing, what they're working on, prioritizes work, etc., and says, yes, this is relevant. Yes, this is what we should be doing. And so for me, it's an extremely important position. It's all volunteer, just like Data Center Pulse. But to make true change, you've got to make sure you're involved. You've got to share. You've got to interact. You have to attend these sessions. You have to talk with everybody. If you don't, and you solve it in your own little bubble, and you don't share it with anybody, yay for you, bad for the planet, bad for business. We need to be able to collaborate and share. That's what these 2 organizations are really about. Okay, so let me give you a little scale of eBay first, set some foundation. And by the way, my presentation title was the Topaz Data Center. Okay, that was last year. I'll talk a little bit about it, but lots more has happened. I'm going to tell you realities underneath the implementation of that data center and what we're doing next. Okay, because I think it's about timely information. So, foundation, baseline of eBay. We have about 2 billion page views a day. Okay, for us it's rather large. If you look at it, we have 260 million plus items for sale at any given second. Okay, that's continuously going up. 23 million lines of source code. So eBay.com is a whole bunch of stuff underneath it to make it work. We've got 75 billion database calls a day. Put that in perspective. It's about 4 times the amount of transactions at the eBay stock, or the New York Stock Exchange. It's just a huge volume of activities happening under the eBay.com website. And we've got greater than 50 petabytes of storage. Let me put that into perspective. Petabytes, 1 petabyte, 1,000 terabytes. 2 petabytes stores every book in every U.S. library. It's like more than 100 times the size of the U.S. Library of Congress. It's just a huge amount of data that we support. And every large internet-based company and almost every company is capturing information about what's happening in their business. And for us, it's transactions, it's clicks, it's what they're looking at, how they're looking at it, when they're looking at it, what they're bidding on, what they're buying, why they're buying it, etc. And you put all that together and you understand your customers. Then you can start to give them what they're looking for, or even things that they may not know they're interested in looking for, based on their behaviors. So that generates a mountain of data. If you don't know about data or Hadoop, who's ever heard of Hadoop? Anyone else know Hadoop? All right. So I'll give you a little introduction to that. Hadoop is a data analytics engine. All it means is there's a huge grouping of computers with lots and lots of storage that basically chunk through all that data and come up with behaviors. For us, it's like I was just saying, what are our customers doing? When are they doing it? How are they doing it? Where are they doing it from? And what do they really want? And so we've deployed some Hadoop stuff, and it's paid for itself already in the tens of millions of dollars in uplift in revenue. Because when you know your customer's happy. You can give them what they're looking for. Okay? That's where this drive of storage is coming from. And what I mentioned before was the $2,000 a second. Pardon me. It's $62 billion worth of gross merchandise value that goes through the site. We connect buyers and sellers, and that's the volume of money that's shared back and forth between all those people. Okay? So, this is what's really neat. You look at this Twitter feed and everything else. And what I sent that didn't get up there was, if I'm nuts, please tell me. Is my thing on track? So continue to tweet. I'm nuts. Yeah, that's good. I should, actually. But this device is $4 billion of that actual gross merchandise value now. iPods, iPads, anything connected to the internet doing something. We released our iPad app. I think we got called 3 weeks before the Apple announcement that the iPad was coming out. 3 weeks. So this is rapid deployment. Our development teams went and created the app, put it on there, and it was $500 million in GMV that first 6 months. Then it doubled, and now it's going to double again, right? We're going to $4 billion going through these things already this year. We believe, truly, and again, think of Hadoop, that this is going to be the way people shop in the future. Imagine if you can go to one application, search for what you're looking for, and be able to see it in a retail store within a 5-mile radius, at the price, and if it's in stock, and online with an auction or a buy it now, etc. Wouldn't you want to go there and say, let me just open this up, scan my barcode. I want to buy it now. I'm going to walk down to Target and get it there. I'm going to go over to Calvin Klein because the store is down the street. Well, guess what we've been doing? Buying companies that do all that stuff. So, Milo.com. All local retailers and their stock now linked back into it. GSI. Okay, that is the one that has 180 brands and all their storefronts. This is Toys R Us, Calvin Klein, etc. All of that is going to be reachable back in through the eBay app. What's that going to do to me? This stuff's going to continue to increase. Okay? The demand's going to continue to expand. So we've got to figure out how we deal with it inside of our data centers. So, did I get that right? There's an error processing a page. Excellent. All right. So, next slide is about our global presence. And we've got about 94 million active users. Okay, so that's active. It's not the 600 million Facebook people. But we are the world's largest online economy, marketplace, because the amount of people that we connect and actually exchange cash. So I think we're in 100 and, if I can remember my slides, 24 currencies, like 190 locations. Okay, so countries. It's all over the world. And we've got a whole bunch of companies. So shopping.com, rent.com, half.com, StubHub.com. We've also got marketplaces, which is classifieds in Germany and Italy and Spain and all over the place. Let's go back 2 slides for me. And so it's not just about eBay.com. It is literally about all of the adjacencies, all the companies that we actually are supporting and how they're converging and how they're basically connecting buyers and sellers, because that's everything that we do. How do we connect them to give them what they're looking for? So, business demand. Before I go into this, we built Topaz, which is our data center in Utah. We finished it in May of last year, opened it up, had a great party, and $287 million investment for 7.2 megawatts of consumable power for IT equipment. Okay, Tier 4. Concurrently maintainable. Maybe not the Tier 4 exact uptime definition, but concurrently maintainable. Why? $2,000 a second. But when I came to eBay, the first thing I looked at was what are we running and what's the resiliency requirements? And what I found was we had a portfolio, a big Tier 4 bucket. All of our stuff was Tier 4. Everything was highly resilient. Everything had to be at a Tier 4 level. No, that's not the reality of it. It truly is that you need to match the applications to the resiliency. Okay? So we had built Topaz to consolidate data centers from all over the US. And we built the justification. The ROI was great because by collapsing into that, we cut our costs in half, etc. It paid for the actual build at the $287 million level. And we won't build another data center like that. Just so you know. I have enough Tier 4. I need Tier 2. I need to go lower, okay? Echoing what Casey was talking about, right-sizing your applications makes a huge difference, and I'll go into those details. But what I wanted to explain is, I didn't want to go into the neat little gold certified lead, highly resilient data center, etc. We all know what that is. We spent a lot of money. It's well built. It was designed well. Actually, Joe's sitting right over there. And we will use it. I just want to extend the life of it. But if you see here, my demand is growing. PayPal, one of our biggest companies, right, completes the transaction, is growing 25% year over year. The demand has continued to increase. Okay? Mobile, as I said, quadrupling to 4 billion in less than 2 years. We know it's going to continue to expand. The listings were 140 million. That's the items for sale. Now they've gone over 260 million. And we have to continue to add capacity to be able to handle that many items for sale and all those transactions. And we're also deploying a brand new search engine, all in parallel of our current search engine. So I can't say with the quantities, but when you build a search engine to serve 94 million users, it's a lot of equipment, right? A lot of horsepower underneath it to deliver for that. Because search is probably the #1 critical component of a successful transaction. If you can find what you need quick, you're going to go back and buy what you need. If you can't, you go somewhere else. If search sucks, you lose money. So we're going right after search and trying to fix a lot of things that were a challenge within our own engine. But again, that's a lot more equipment landing in the data centers, more than we expected. On top of that, you look at the data growth. Greater than 500% growth in less than a year. Okay? So that 50 petabytes I talked about, I've deployed it in 3 months. 50 petabytes of capacity, okay? It's freaking massive. Just for everyone who's done data before, it's just a lot of data that has to be deployed out. A lot of capacity for it. And on top of that, our power is supposed to be doubling. So I've done a 10-year forecast of what our projections would be. And based on the information we had, right, with a 5-year horizon and a 3-year real, what we're going to make decisions on, but understanding what the long-term view is. And just looking at it, in 5 years, if my power is going to double, all those things I was tweeting about, as Casey was talking about, I'm on Rocky Mountain Power's power grid right now in multiple states and having conversations with them and the local governments, etc. Okay, so you can see some of the business demand that's happening, right? This is what keeps me up at night. How do I make sure we're going to not be in the way and we're going to grease the skids and enable the business to go as fast as they want? Because, by the way, you noticed Microsoft bought Skype? Did you know we owned Skype before? Did you know we sold it? And then they sold it again? So in the end of it, we own 30% of that stake. So we got $2.4 billion of that transaction. Thank you very much, Microsoft. And the net of all that was $1.4 billion gain for the company since the beginning of that transaction. What does that mean? We're going to buy more companies. What does that mean to me again? Oh my God, we got to deal with it in the data center. So here it comes. What I want to do is build an infrastructure that allow us to say, however fast the business wants to go, we've got to be able to support it. Period. Okay. How we've done it in the past, as I mentioned, can't be sustained. We can't continue to do it the way we did. And so we've been spending, I've been there almost 2 years now, focusing heavily on what should we change, what is the long-term strategy, and how do we deploy that. It's not something you can do overnight, right? Assessing what you've got to truly understand it, and then getting it all the way back up the chain. And that organizational structure helps quite a bit to get that approval. So I'm going to share with you now what we've learned in that journey. And feel free to ask questions, by the way, if there's something here that you want to know more about. All right? Can make this interactive. Right-sizing applications. You can hear an interesting theme here. It cuts your OpEx and CapEx in half. Okay? Real numbers. This is my CapEx and OpEx. When I can now build a Tier 2 data center that's augmenting my Tier 4 site and expand my capacity within that site, my overall costs lower in a huge amount. Okay? Tier 2, of course, is cheaper to build. And now, with the way things have gone, it's even cheaper than that. The way that the costs in the Uptime Institute from a Tier 1 to Tier 4, just completely out of date now. Out of date. As we go to Tier 2, they just continue to get down towards the lower than 10 million a megawatt. And depending on how you do it, we're doing some future-proofing inside of that to ensure that we're going to be able to handle the future, all the different type of products that are coming out. So we're spending a little bit more money up front. From a capital standpoint, it's a breeze because the depreciation is over 25 years. So adding larger pipes, adding in more connections, adding in all the expansion is really important. So, right-sizing your applications. You know you'll save money if you can merge those teams to understand what it is that they need from a resiliency standpoint. Second part is server SKU consolidation. Okay? Okay? This is the amount of configurations that you're buying. What we found is we had a ton of them. Everybody was building a server for this function, or for this pool of application support, or this database, or these things. And they were all negotiating different purchases, right, from different people, and it was just a huge, homogeneous mess. Now we went back and said, what's common, and could we come down with a smaller number of SKUs? And what we've come up with is 2. And I'm really happy with this. We've consolidated to 2 SKUs for 80% of the equipment we buy. Okay, for us, that's important, because I've got one for Hadoop, as I mentioned. Hadoop is a very different animal, because today you have to have local storage on the server. Okay, we're putting drives inside of the actual server. Again, because there isn't a solution that's going to give me the I/O performance over the network, over a SAN, over InfiniBand, etc. They haven't quite cracked that nut yet. They will, and we really need it to happen. But right now it's just about cheap drives and a simple processor itself to be able to now capture the data and start chunking through it all. So that's one SKU. The second SKU is everything else. So that's a new search engine, that's a new application deployments, it's all that. It's really, really good. Okay? So now when I've got those 2, I can start to do a real holistic TCO model. Okay, all of my folks inside of operations, my peers, we are all inputting the costs to deploy an application. Just like Casey was mentioning, it's all about what are your total costs inside of the data center to deploy something. And that changes buying decisions. And what I mean with that is I was at the Uptime Institute session, I think last week or whatever it was, and we were having a lunch, and I got up and said that I think I have the best job in the industry. Personally, I'm the data center guy and the network guy. But I'm awarding server contracts. Right? My peers have basically said, yes, we trust where you're going with this. Right? You can go back and award these contracts and negotiate what's happening. Why? Because the wattage consumed in the server over its useful life inside of a data center is the real cost. Who's got the largest cost? I'm half the OpEx for the entire operations team. And our power is going to double, we'll continue to consume more and more of that OpEx. So now we can truly say, I want to get to a unit cost in this server, but I also want to know what my wattage cost is going to be over time with the useful work, right? The actual load we're going to have for doing search or other functions on it over its useful life. When you truly see that, it changes it. And I'll give you an example. We had I think, 17 vendors respond back to our server RFP. We put out the new search engine RFP, thousands of nodes that are going to be purchased. And they came back with unit cost and all the different spec power numbers that we plugged into our model. So when we just looked at the servers of the final 3, one guy looked really good from a price standpoint, the others were higher, but then we plugged in all the wattage numbers, and it shifted. Why? Because it was more expensive to deploy that cheaper server, because they consume more watts to do the same work. Wow. And we awarded it to the different vendor. Okay? I mean, we're talking $20+ million worth of hardware that was purchased just like that. On top of it, we now went back and said the next one is Hadoop. We gave feedback to all of them again on why they lost. And they tuned their equipment, and guess what? They won back the next round because they went and changed the fins on the CPU, the low voltage DIMMs. They tuned the whole box. On top of it, we said we're deploying these inside of containers. Okay, so we want to do 960 or 1,920 servers at a time because our 2 SKUs are racks of 48U, 30 inches wide, 48 in deep, up to 3,000 pounds or 3,500 pounds, right? 48 servers for Hadoop because of the storage, 96 servers for everything else. It's dense. So they tuned the entire box, the containers, with the servers and warrantied everything at the higher temperatures. And I'll go into that in just a minute. All right, so comprehensive RFP process. Yes?
Do you have any blade servers?
So right now we've done analysis, do we have any blade servers? Today we've been doing 1U and chassis-based stuff with 8 servers in it, like a blade server, but we don't need the intelligence, right? So we are always analyzing whatever options are out there, and if blades come back and actually give us that function at the right cost, great. But right now you're paying kind of a premium for the intelligence side of those blade servers than you would within the other units. We've got a lot of intelligence. You saw the 24 million lines of source code. We have a lot of intelligence upstream. We just need compute power, and we do capacity management and control it, and we know what our workload is. So we can map all of that. All right, so comprehensive RFP process, as you said. Now, let me share with you some of the actual data. I had to take out all the prices, so I make sure I stay employed. So if you look at it over here, so maybe we'll do this. This spot, number 3, this is an analysis we did for 2,000 servers. Okay, so it's like an instance or something of one of our search things. And we said, if I ran a server at 2.93 gigahertz, 6-core processor, for me to go deploy that in a data center for that many nodes at different densities, so this red is at 14 kilowatts a cabinet, between 11 to 17, and the bottom one is up to 28 kilowatts a cabinet. Okay? So, if I do that, you can see that right now, just the data center costs, this includes the infrastructure depreciation, the all-in utilities for the usage of that equipment over its time, and then the rack networking, etc. All the other support components for deploying that server. This, right now, I can see that it's cheaper for me to deploy in density. And the reason is, I have less cabinets. I have less infrastructure I need to have. I have less cabling. I have less everything because I have a smaller number of cabinets. So density gives me that. Then, if I wanted to do the same useful work, because a lot of people came back and said, hey, well, why don't we just get cheap servers, right? Cheap servers with the lowest wattage CPU and buy more of them because they consume less wattage. Okay, sounds interesting, but the problem is, to do the same useful work, I have to have 2,593 of them. If I do this lower frequency, 2.26. And you can see, so there's not much difference in the 14, but it starts going up quite a bit in the higher density. But if I go down to the even lower extreme, I need like 3,600 servers to do the same work at 1.6 gigahertz processors. It consumes more power overall because I just have more equipment. On the other side, you can see, well, why wouldn't I go to 3.46 gigahertz? Same thing, I'll just do a faster processor, get less machines that way. But you pay a premium on those processors. They're very expensive. Right? So we found the sweet spot. It's right there. We also found the density sweet spot. It's 28 kilowatts. Okay? Now, this is just the data center. This is all in. This is the server costs. This is the software costs. Okay? And by the way, the numbers before were like a third and it quadrupled almost. We start adding all the equipment on top of it. Servers are expensive. But you can see it starts to flatten out. But the sweet spot stays the same. So I'm focusing on density. It's important for me to go back and deploy this because I also own the asset lifecycle. So asset management, logistics, etc., the birth to death of the equipment. So we know what that is. And if we're doing the supply chain, what is the best value in the supply chain? I hand an RFP to somebody, they rack, stack, cable, image, everything for me, and it rolls in and I plug in power and data, and I provision. That's saved. I do all the hands. Inside of the data center, guys doing the cabling, racking, stacking, that goes away. All of a sudden I can just get capacity. Okay? But the key in this is the sweet spot we found for our business, what works for us, is to go dense and optimize for the CPU processing speed. And we'll tell you that a Hadoop configuration is I/O intensive, so you can't take advantage of the CPU as much. So all of our other ones are at the 2.93 or 3.06 because it was the next gig processor, and the other ones are at 2.4. And what we're doing in Hadoop is we're buying all the servers at 2.4 gigahertz processor, but we're downclocking them all to 1.6. Reason is, at 2.4, I have like 5% utilization on the CPU because it's just waiting for I/O. So we drop them all down, and suddenly I got 40% utilization on the CPU. Because it can take a little longer for it to do the work with a slower frequency processor. But I'm working with the director that runs all of data analytics, data warehouse, etc., and he's tuning Hadoop. And as that continues to go up and they figure out use cases to increase the utilization, I just step up the frequency. I've just given myself 2 years of runway without having to replace the equipment. And that holistic RFP process gave me great cost advantage when it comes to deploying equipment in volume. Okay, so rack density for us is required. It really is important. I got 15 minutes, all right. So you can see the two configurations, Hadoop and everything else. And you saw that it's less less density actually costs us more money to deploy. And now we're doing rack and roll. So this is the one I was just talking about. I can now do optimized overall supply chain because I can put the RFP out, whether I'm doing a single cabinet or whether I'm doing a container of stuff. I can get the stuff provisioned out quickly at a cost-effective manner. And cache on demand. We're going to have triggers that says whenever I have a certain amount of capacity, I hit 80% of that capacity consumed, order the next round. Every month, we're putting out another RFP for who's going to be supplying the new equipment. And they know how to win when it comes to wattage and overall cost per unit. So cache on demand is important. And again, single rack to that. Modular data center design, of course, important. We're doing this all over the place. I'll show you a little bit more about that. But multi-tier is really important. And we're doing it in 2 megawatt chunks. And multi-loop cooling. So the new data center we're deploying in Phoenix is adjacent to our Tier 4, and we're using hot water cooling. Hot water cooling, make sure everyone gets that right. So it's 87 Fahrenheit supply water. Why? Because 87 degrees is the maximum temperature you have to cool in Arizona on the hottest time of the summer. So why wouldn't I start there? Everything else gets easier. So we supply at 87, and as I said, 130 C is what the chips can operate at. I absolutely agree. We baby these servers. We don't need to. The warranties on the server equipment itself is much wider than people think, and all you do is sit down with the manufacturer and say, this is what I'm deploying, and they warranty it to that configuration. So for those in the room that are actually doing, hold on one sec, that are doing integration of containers and equipment, my personal opinion is that if you don't have a partnership with an HP, a Dell, or anybody else that's going to have equipment going into it, that's going to be able to warranty, certify that configuration, it's not going to work. Consumers like us are not going to go buy servers from one thing, put it into a container that's potentially going to void the warranty because they weren't integrated right. Okay? There's tens of millions of dollars of impact or risk if we do that wrong. So, just some input on that. Figure out how you can get a supply chain that's actually partnered up with people that's going to be certified to deliver to someone like us. Okay. Limits of air cooling is another interesting thing. We just did, because we awarded the contracts, I can't say who the vendors are right now, but we started tuning the box and we found out that with density inside of a smaller space, there's only a certain amount of air you can push over that equipment because you just, laws of physics. And what we found is, it's 28 kilowatts. This seems to be the magic number. If I go above sustained 28 kilowatts a cabinet, it will start to reheat over time. You just can't get enough, right, from air. So now I know my limit. And for those of you who know me, my next thing is liquid. Liquid cooling, okay, is the future when you start to hit these densities. And I'm pushing for it. Imagine 87 Fahrenheit water to a chip. That's cold bath for a chip. Okay, at 130 C, right, the internal temps. I mean, it's like 40 C delta before it will self-throttle at 100% workload. So we've got these, anyways. The point is, we know where the air hits the ceiling. So why wouldn't we design and plan and enable the future? The data centers we're building right now are for that future. I'm getting the best benefit today when it comes to air. How do I optimize for it? But I hate air. I don't want to use air in a data center. I want to be able to be efficient. Like fanning yourself outside versus jumping in a pool. You kind of cool yourself off faster if you jump into a pool. I want to do something similar in that in data centers. And I don't care about liquid in data centers. It's been there from the beginning. Get over it. Okay? We're going to deploy it, and it will happen, and it'll be fine. We're designing to it. All right. You can tell I have an opinion. So holistic computer engineering. What I just mentioned, remove the massive compounded overcompensation for cooling. That's a mouthful, but it's true. Think about the servers themselves, all the way from the chip. They compensate because they have to be selling this all over the world, so they make sure they've got buffer in the chip, then buffer in the server, then buffer in the rack, then buffer in the room, then buffer in the chillers, then buffer in the towers. I mean, it's just insane the amount of cooling waste that we have. Okay? So we want to be able to do it from the chip to the tower. If you notice, I'm tuning for 2 variables. The max outside air temperature and the chip temperature, because that's the hottest spot inside of the system. So if you tune to those 2, everything else works around it. Why would you do it backwards and say I'm tuning to the cooling in the room and then everything else has to match to it? It's backwards to me. Okay, horizontal and vertical scale. This is also really important for us. Horizontal scale. I want to be able to create lots of lanes in a freeway. How wide do I want my freeway? And think of a lane as a rack of equipment, 96 servers as a failure domain. Okay, how many racks am I going to have deployed for the workload over that time frame? It may be low on a certain day, so lower the amount of lanes you have. Shut off the other equipment you don't need. Use what you got to use for that point. We know what our workloads are, and we see the triggers. Add another lane. Add another lane. Okay? That's based on latency. If I got a search application, it's important that they do it quickly. I can't slow everything down from a processing standpoint because I'll lose customers. You want your search to go slower because I'm trying to conserve energy on the other side? No, you want what you want right now. So we need to be able to have the lanes go back and forth. That's horizontal. Keep it at the same speed, but give yourself more or less of them. Okay, the other one is vertical scale. For the stuff that can take advantage of it, I want to be able to overclock the processors and underclock the processors. Okay, this is about, well, how much speed do I need at what time? And you know cloud, everybody's been talking about cloud. We talk about burst capacity. So the burst capacity for us, we've got a partnership with Microsoft Azure, and so we've got our own cloud we consume internally. And when we start to look at the workload, as it starts to get high, spikes during times, if it goes over your capacity, you burst outside to someone else, and they handle that overcapacity. Okay, great. Sounds good, but you pay for that burst too. Okay, I only want to do that when I have to do that. So why wouldn't I get more out of the equipment I have? So why wouldn't I give myself a gas pedal that when it's starting to go up to that peak, why don't I just turn on turbo mode and give myself more capacity to handle those peaks? I may not have to burst outside. If I do, I got a backup. But why wouldn't I get the max I could out of those processors? That's vertical scale. I need a gas pedal. Okay. Optimize CPU temp cooling systems, so that's where liquid starts to come in. How do I tune to make sure that I'm giving the maximum performance and keeping the chip operating at its best parameters within the parameters so we can get the most out of it we can? And of course, 25 kilowatts and overclocking does require that new cooling solution. We want to create a finely tuned engine. I want a gas pedal. That's what we're building, a gas pedal for the data center. And that ties right back into the performance. You notice I want to be able to have a Prius with no gas consumption at all when I'm low, and then I want to be able to have a Ferrari, but it's the same car. So how many lanes you have from a horizontal standpoint, and how fast are you going on those lanes? Is it the Autobahn, or is it 101 at 5 o'clock? So we want to be able to just manage that, okay? So here's an example. This is the first Cassini deployment. That's our new search engine. This is 96 servers in a cabinet, 4 switches, 28 kilowatts of redundant power, capacity. It's 3,000 pounds. The Hadoop ones are 3,500 pounds because of the drives. They're just a lot heavier. But imagine I'm rolling those into the cabinet and I'm deploying them in hours into the data center. Okay? I'll let you soak in on that one a little bit. Okay, and then the next one is Project Mercury. I'm sorry, yes?
You said you have redundant power there?
Yeah.
AC, DC?
It is AC. And actually, that's a really good point. We went through an entire exercise of trying to get down to single power supply, single cord, single everything. And I was all over it. Yes, we could do this and get things down to where we need to. But then I realized that forcing that, we had to put these in Project Mercury. I got tier 2. So if I want concurrent maintainability in a tier 2, sounds weird, but I don't want to shut off my equipment when I'm doing maintenance. I still want to be able to have that capability to say, I can do maintenance. I'm at a higher risk because I may not have all the stuff on redundancy, but I want to be able to do maintenance. So we put these massive static transfer switches up in front of them so I could have a single cord. This is like a 17-foot, 4,000 amp, I mean just massive static transfer switches to be able to handle what? A couple $100,000 in savings in power supplies, etc. inside of the servers. I think this is bass backwards. Why am I doing this? And we looked at it. That was the biggest risk in the whole project because we couldn't figure out the controls to be able to have the static transfer switch with the generators and everything work together. So we said if that's the biggest risk, remove it. And so we went back and said, I'll spend a couple $100,000 more on dual power cords. So I've changed my stance into, that makes sense. Now I can get concurrent maintainability at a tier 2 price without having to bring my equipment down to do maintenance. Project Mercury, what you can see here, this is the building that we built last year. We're literally right in the middle of doing the construction for the plant and everything else. And we'll have containers on the roof, modules. And we're going to have the high density on the ground floor. So 4 megawatts day one, we doubled that within a week because Cassini came, Hadoop came, and now we can handle another 2 megawatts on top of it. That's great, 2 megawatt chunks. It's already designed to handle 6. That's how much power is coming to the site for us, but it's designed to handle even more. This will be extremely dense, okay, because density is important to us. And the hot water loop and the 55-degree loop, we have the option to plug in anything, anywhere. So on the ground floor, we've got a 5-foot raised floor with no cooling. It's just for piping infrastructure support, okay? Because we're going underground to go to the actual plant. So we have a large floor. But then I've got the ability to plug in, a in-row unit with liquid, high temp or cold water. I can also put in passive doors, or I can go direct to the cabinet. So I can basically handle whatever's coming and plug into that. And it gives me runway in my data centers. I'm not bound to one specific solution or one vendor, etc. It's 87 water and 55-degree water. What can you give us to give us the highest efficiency? You have a question? So the inlet temperature to our servers is still being adjusted. Remember, 87 Fahrenheit water is the max on the hottest day of the year in Phoenix. But it's going to get cooler in the other times. So we're looking at least 78 or higher on the air-based solutions, but on the containers, because we're not going to have people in there a lot, it can go up to 95. That gives us failure rate on our disk drives, completely warranted. I have Hadoop in containers. We maybe have a couple failures a week on the drives. We do not see an increase with the higher temps. Okay, so that's another myth that's been out there forever, that the server manufacturers want you to be really careful because it's simpler for them. But when you look at the MTBF, is anybody giving us data that says I got 4% failure increase over time because I went up by 3 degrees Fahrenheit? No. We buy tons and tons of this stuff, right? You have failures, but if you buy 10 servers and you have 1 failure, that's bad. But if you buy thousands of servers and you have 10 failures, who cares? We have not seen an increase. And we've increased the temperatures in our current data centers, and we're still not seeing an increase. Failure rates are the same. Again, we baby these servers. They can handle a lot more than what the design is set for. And when you sit down with the manufacturers and have that conversation, the engineers already know what they've done these tests. They just have to do RoHS and all the other certifications for the world, and so they're very, very safe. That's why the ASHRAE things were like this, and then expand them out to here, but you can still expand them out even further. Backup what? So we have, in this data center, we've got UPS. We have UPS to one feed, and we have street power to the other. Okay, so we decided that from a tier 2 standpoint. I just want to be able to have 60 seconds to be able to flip over to the gens. But on the other side, if I'm doing maintenance, we know that in here it's a tier 2. It will take a hit at some point. But I'll minimize how much hit I can take. Might as well. Right? Does that make sense? Okay. Sorry, was there? Yeah.
So I'd like to get my director and my manager to come here because I'm getting beat up constantly. Like I'm dropping discs, it's hot.
Which company do you work for?
Regents, Blue Cross Blue Shield.
Regents. Okay. And so you're in which group inside of Regents?
I'm data center operations.
Data center operations, right. So the IT team is telling you everything's failing?
The manager is. He's a little bit more
Conservative?
If you will, yeah, absolutely. From our standpoint, everything's fine. I mean, we just did a new cooling system, water side economizer.
Yep.
We are learning curve a little bit because we're adjusting it up to about 70 degrees Fahrenheit. But he is seeing some temperature spikes. And we're seeing some
How old is the equipment?
Some of it is about 12 to 14 years old.
12. Wow. It's only 12 to 14 years old, huh?
Well, you see, and I guess part of it is me being, I guess if you want to say the bottom level, even though I'm the one that's supporting all the equipment.
Yeah.
I'm the last guy at the bottom, so he's trying to figure out what's going on, and if I don't have a lot of control to say, hey, listen.
Yeah. I can talk to him. Place your damn equipment.
Yeah, exactly.
And I'll tell you right now, the ROI on replacing 12-year-old equipment, I don't know, it's like 13 minutes. Seriously,
What I would like to elaborate on that is, I don't necessarily have a lot of control on the funds, and you know, we're a health insurance company, so there's some HIPAA rules and that sort of thing. But part of the problem is I'm not able to articulate up the chain.
Gotcha. So this is a perfect example to me of where you've got a facilities team, it's handling all the data center side, and an IT team, and they're not meeting. Does he pay the power bill?
He does not.
There you go. So he doesn't care how much it costs to go deploy those. Well, he may, but he doesn't see it, most likely. And so when you start to marry those together, that's where that ROI comes in. He's going to like quadruple or 10x his performance in the compute side, right, for maybe a third of the cost on the OpEx. Because the servers today are just insanely more efficient and more powerful.
There's not a lot of those. There's just a few.
Yeah.
He sees it. There's the spike. He's like,
Yeah.
what's going on?
I'd love to talk to him. Casey?
So Mike has maybe addressed it. Dean is absolutely correct. You should replace those servers, but the average life of hard drives is 8 years. And the bottom line is Dean's right. You'll replace them, you'll actually gain efficiency, more compute capacity, you'll actually gain what I call virtual data center capacity. But the other thing about this too is, if you go to SNIA, that's a storage,
SNIA, yeah.
They actually have some studies on this, and they basically show that temperature is not what causes hard drives to fail. So I'll get back to your question. Rapid temperature changes can cause hygroscopic, minute water droplets on the drives. That can cause problems. But that's extreme rapid changes, going from 50 degrees to 150 degrees within minutes. Not anywhere near what you're talking about. That's not going to cause a problem for a drive.
Yeah, I'll bet you get vibration issues in yours too.
That could be too.
Vibration on old drives is horrible, right? Because it causes drops. Any other questions? Yeah. 10G, yes. Okay, so we're doing 1 gig interfaces to the servers because we looked at the workload itself, and they weren't pushing, and so we've got 2 interfaces per server, but then it's 48 port switches to 48 nodes. Okay, and then it's got four 10 gig uplinks as well. So for the index nodes we have, they start pushing 2-3 gigabits. So we've got 10 gig to those, but it's like 1 rack out of 40 or something that has to have 10 gig. But we can have the same thing. By the way, in that rack, I don't know if you noticed here, you see up here, those are 2U cutouts, vertical cutouts. So now I can put 2U switches, load balancers, anything else I want inside. All of the other stuff is compute. And so it also handles front to back or back to front cooling or side cooling, etc. I can plug in any kind of vendor in there. So I can get to 10 gig no problem. And if we start to have a need for it, my next RFP, it's 10 gig versus 1 gig to the server. To the server, yeah. And I believe copper is going to be the right one, but we got to balance if the copper has more wattage consumed than fiber from a 10 gig link. I believe it does. Yeah.
What do you find you're using the lower temp chill water for, and what percentage are you using?
So what percentage of the cooling are we using with the lower temp water, right? That's why I was really pleased in this process. We put out the thing of we want free cooling in Arizona year round. Okay, so hot water cooling came out of that design. And that's where we found out the temperature spread within the region. And so when we kept pushing the vendors, we now found that one came back with a garden hose, and it works, okay, to a container. And then we have other ones that are now saying, I can use the hot water cooling direct to it. Uses less space, and it can get to those higher temps, and it's tuned. And by the way, we have 40-degree delta T on the servers. 40-degree delta T, extremely efficient. Really balances your cooling infrastructure. Okay, and they certified all that. Then they could start to raise the temperatures up even higher. So I'd say from a percentage standpoint, we're going to be using probably 70% of the hot water cooling side and 30% of the chilled water. But over time, because we're doing it in 2 megawatt chunks, I can decide if I want to do more 87 or more 55 as business comes up.
Any waste heat link?
We haven't found a way to use the waste heat like in Europe, right? They use that quite a bit. That's the climates and everything else. We just haven't had we can't find a way that would be useful in the centers. I don't have a greenhouse next door. I don't have district heating that I want to plug into. I don't have, you know what I mean? There's not much infrastructure around to be able to take advantage of it. Yeah.
A question on the CapEx, OpEx decision. How do you make a trade-off on payback in terms of time for payback on CapEx?
Payback for us really is if it's 3 years or less.
3 years?
Yeah. But the majority of these, I mean, are like 18 months or less.
Just a follow-up. Your company's obviously combined CapEx, OpEx decision-making.
Yeah.
In the industry, is that a trend? Do you see that happening?
I still think this comes down to visibility. So if a management team understands the CapEx and OpEx implications of the decisions, then it works, right? But if you've got a facilities team trying to tune PUE and isn't working with the server side, so they're raising their inlet temperatures and then all the fans in the servers go 100 miles an hour and their savings just go like this, right? But when you start to have the conversations, just like we said, that holistic TCO model, then you really know what it costs you to deploy something. I'll tell you, the CFO loves to hear that. Because ultimately what we're getting to is, well, we want to deploy a new mobile application or a new thing like this. How much will it cost us to do that? What's the return from a business standpoint? For the cost of this, what's the revenue that's going to come out of it? So, and that's why I would rather have my car running at Ferrari speeds 24/7 for 2 years. It's very efficient to do that if I could optimize for it. Because at that point I know I'm getting more and more transactions. If I'm making money with it, why wouldn't I do that? It's a performance car. But if I need less, then I back off to the Prius. Any other questions? Yeah.
One question. Sorry about that.
Sorry. I missed you over there. I'm sorry.
You mentioned 2 megawatts multiple times. Why 2 megawatt increments?
2 megawatts from a capital standpoint for us to deploy like generators and towers and chillers, that made sense. There's kind of an economy of scale there if we get the bigger ones. If we do 500 and that, it just isn't giving us the capacity we want. Also, it still takes time. What we built in this center is we're doing it in half the time for like a quarter of the cost of what we've done in the past, which is great. But I want to be able to snap in larger chunks. And the trigger with our company to our CFO is we're going to do it 2 megawatts. It's not worthwhile for me to go back up and ask each time we're going to go do 200 kilowatts or 500 kilowatts, etc. Now, that module size may vary with everybody. It may make more sense for companies to deploy 500 because they don't have that much equipment, or even 200 kilowatt chunks. But the whole point is chunks, modularity, build for your end state, and then work backwards from there on what you're going to deploy day one, and then as the business changes, adjust the growth. That gives you the runway, right? I know my capacities for that site. I know when I'm going to have a trigger, when I'm going to build the next site, when I'm going to build the next tier 2. Yeah?
Are you planning to use EFDs in your data center pretty soon?
Use what? I'm sorry?
EFDs, flash drives.
Hey. So, right, solid state drives, SSDs. I really wish we could, because the wattage is great. The problem is the cost is still there. Now, this has driven the cost down. Right? The flash memory market and all that, because of the volume of things here, it's gotten that back down. Japan's kind of hurt that with the latest tragedy over there. Supply chain has been really, really bad. So if you look at your iPads and everything else coming out, they're eating all those costs on the other side to ensure that they can still deliver, but you know, the margins are getting lower, at least for this time frame. We would love to have a SSD solution for Hadoop, but I can't justify from a cost standpoint. We are looking at SSDs for the boot drives and other caching type things inside of, say, search nodes and that type of thing. But we haven't really got to the point where the price makes sense yet. But it will, and it should. The spinning media is horrible in a data center. There should just be chips. Then we can make them hotter. Any other questions?